Let's take a look at how we can solve a system of equations using the substitution method. So we're given this problem here. On a rural highway, a police officer sees a motorist run a red light at 50 miles an hour and begins pursuit. At the instant the police officer passes through the intersection at 60 miles per hour, the motorist is 1 mile down the road. If both drivers maintain a constant speed, when and where will the officer catch up to the motorist? So first we'll need to identify our dependent and independent variables, and then we'll write a system of equations in two variables to model the situation. And then we'll solve using the substitution method and check our solution and be able to explain the real world meaning of this solution. So let's start by first identifying our dependent and independent variables. So in this instance, what we're looking at is we're looking at miles per hour. So we're looking at distance and time. And I always think of time as my independent variable because no matter what we do, we can't get time to stop, right? It just keeps on going independent of anything else. So our independent variable, our x, will be time, and that's in hours. And then our dependent variable will be y, and that's going to be the distance. And that is in miles. Okay, so we need to now write a system of equations for these two vehicles. There's the motorist and there's the police officer. So let's look at the motorist. Okay, so I'm going to start out by writing y equals, and that's because I'm looking at the distance, the location of each of these people, the motorist and the police officer. So the motorist runs the red light at 50 miles per hour, and then when the police officer passes through the intersection at 60 miles per hour, the motorist is 1 mile away. Okay, so the motorist starts at 1, and then for every hour that he drives, he's going to go another 50 miles, right? 50 miles per hour. So starting at 1 plus 50x. In intercept form, right? 1 would be my y-intercept. That's my starting position. And then 50 is my slope, is my rate of change. So that's for the motorist. I'll write that there, motorist. And then for the police, it's going to kind of have the same setup. We're still going to start with y equals. We're trying to kind of think about the distance, the location. And he's starting at 0, so I don't really need to write anything. He's going 60 miles per hour. So for every hour, he'll be 60 miles down the road, but he's starting at 0. Right, he's starting 1 mile away from the motorist. So now I have my two equations, which creates my system of equations. Okay, and what we're going to do is we're going to use the substitution method in order to solve this system. So I want you to think about how we have y defined twice. We have y equals 1 plus 50x, but we also have y equals 60x. And the y in this case is referring to the motorist, so the motorist location. And then the y in this case is referring to the police's location. We want to figure out when the motorist location is equal to the police location. So what we can do is, since I have y defined twice, I can take this 60x, right? Because y equals 60x, and I can take that and I can replace it I can substitute it in for this y. So now I'm going to rewrite this top equation, but instead of writing y equals, I'm going to write 60x equals. So it turns out to be like this: 60x equals 1 plus 50x. And now I no longer have an equation with two variables. I have an equation with one variable. And that means I can go ahead and solve for that variable. So I need to get my x's all on one side and my numbers all on the other. So I'm going to take this 50x and I'm going to move it over here to be with this 50x. These 50x's cancel out. So I have a 1 on this side, and that equals 10x. And now I want to get x all by itself, so I need to divide both sides by 10. And x equals 1/10. Remember, that's the amount of time. So 1/10 of an hour. 1/10 of an hour, we can write that. And then what we need to do is we need to plug in this value for x into one of our original equations, because for a system of equations, our answer is always two numbers. It's an x and a y value. We need both. So right now I'm halfway there. I have my x value. Now I need to figure out my y value. And again, I can do that by plugging it in either into the x in this equation or the x into this equation. It doesn't matter which one, you can choose. I'm going to plug it in to this second equation. So I take y equals 60x, but now I know x equals 1/10. So I do y equals 60 times 1/10, right? Or y equals 60 over 1 times 1 over 10. That equals 60 over 10, which just equals 6. So y equals 6. And that's my complete answer. I have my x value and my y value. And I can write it as an ordered pair, right? That's my x and my y. And then let's explain the real world meaning behind this solution. So if x is 1/10, well, that means 1/10 of an hour. And then if y is 6, y is my distance, so that's 6 miles. So in other words, it took 1/10 of an hour and 6 miles for the police officer to meet up with the motorist. It took 6 miles down the road. And 1/10 of an hour is just 6 minutes. It's just 6 minutes, right? 6 times 10, 60. And then one other thing I want to do is check my solution, okay? And the way that I do that is I plug in my x value into x, my y value into y, and I check to make sure that both of my equations are true, okay? So I plug in 1/10 for x and 6 for y. Let's do it in this top equation, y equals 1 plus 50x. So I plug in 6 for y, and then 1/10 for x. So 50 times 1/10. So 6, and I'm checking to see, is this true? Is 6 equal to 1 plus 5? Yes, it is. So that worked in this first equation. And then let's do it in the second equation. So I plug in, I'm going to just erase this if I can, I think so. So now let's plug it into the second equation, y equals 60x. So 6 gets plugged in for y, and then 1/10 gets plugged in for x. And I'm checking to see, is this true? Is 6 equal to 60 times 1/10, or 6, right? So yes, that's also true. And that might seem a little unnecessary to do sometimes, but it's a really easy and quick way to check your answer and make sure that you're getting the right answer. If you ended up with the wrong answer down here and you tried to plug it in, then you'd get something, like 5 equals 15. And it's like, no, 5 doesn't equal 15. So again, it's just a really easy way to check your work, right? And there we go. That's the substitution method.